thank you very much, and thanks so much for the invite. It's a pleasure to be amongst such kind of heavyweights in the field. So, yeah, consider this a bit of a transitional talk from like a psychedelic heavy narrative to breathwork as a kind of different modality to induce altered states of consciousness, but there'll be a lot of kind of psychedelic discussions within that. So I'm going to start from the start and just talk about what breathwork is. Fundamentally, breathwork is basically a practice to induce an altered state of consciousness through the modulation of your respiration. So it's like meditation. It's a kind of umbrella term for a variety of different practices. And what we were kind of interested in within the study that I'm going to talk about is something called high ventilation breathwork practices. So there's a really cool study from Cox and colleagues in 2014. Let's see if this laser works. Somehow, yeah. So if you look up in panel A, you can see that there's a participant doing this breathwork practices where they have rounds of hyperventilation followed by rounds of breath retention. And as they as they go on and do this breathwork practice, you can see that as they do these breath retentions, their kind of aspects of their physiology are modulated. So blood oxygen saturation drops deeper and deeper as they kind of continue further on into the practice. So the idea here is that you're modulating aspects of your physiology through the modulation of your breath. I love this picture on the left because it makes Stan Grof look like a crazy guy. But he was the kind of, I'm going to talk about like the origins of modern breathwork, not just kind of pranayama as a kind of ancient technique, but like more kind of modern aspects of breathwork. So they kind of share a history with psychedelics. So Stan Grof, he was an LSD and psilocybin psychedelic psychiatrist from the 1950s and 60s. He supervised over 4,000 LSD sessions within that time. But in 1971, the Convention on Psychotropic Substances put a halt to all psychedelic research. And so Stan Grof had this kind of powerful tool to kind of reveal aspects of the unconsciousness with psychedelics, but he had to move to a separate modality after this. So with his wife Christina, he co-developed something called holotropic breathwork as a non-pharmacological kind of psychedelic adjacent altered state of consciousness that had these kind of mind-revealing properties. So fast forward to today, there's actually a lot more kind of interest in the kind of popular media for breathwork. This was a New York Times article from 2024, I think. So it shows that we're kind of moving, like the hype cycle of psychedelics as well is coming with a more like appetite towards breathwork as inducing these like altered states of consciousness. So what does the research say? What is the similarity between breathwork and psychedelics? Well, there's actually not a huge amount of research, but we'll kind of find out from Martha and a few other colleagues later on about some cool research that's been going on. But this is a study from Camille Bahi and colleagues in 2023, showing that breathwork can actually induce these similar phenomenological properties to psychedelics. So they use these Likert scales to basically index the breathwork state. And you can see that on a variety of dimensions on the 11-DASC, they're similar to a medium dose of psilocybin. So that's quite interesting from a kind of consciousness perspective, that you can allegedly get to the psychedelic state just through doing this kind of heavy breathing for like an hour. It's very interesting. So this is our research question that we kind of fundamentally had for the paper that I'm going to be presenting today. To what extent are breathworks and psychedelics similar at both the subjective experience level and the neural level as well, so when you're looking at brain dynamics? And I'm going to kind of be banging on the neurophenomenological drum as Chris was yesterday. So I'm going to be talking a bit about neurophenomenology. I won't go into too much depth about the ins and outs of it, but basically as a primer again, neurophenomenology is pairing objective measures, so looking at brain dynamics like EEG and fMRI, with subjective measures, so asking a participant if they're doing a meditation session or breathwork session or psychedelic session, how they felt during that session. And so we're moving away from this idea of altered states of consciousness, looking at the broad kind of umbrella term of breathwork as a state, to looking at the more kind of fine-grained aspects of the experiences that breathwork can generate and how these are related to neural dynamics as well. So we can actually understand that these neural dynamics are tied to these specific experiences that this kind of phenomenon can induce. But there are some kind of difficulties when we're asking participants how they felt during these kind of altered states sessions. So, Likert scales definitely have their role in mapping out a broad idea of the state itself. But it feels kind of silly to be able to kind of compress the value of an intensity or bliss or spiritual experience, whatever you want to kind of index, within an altered state session into one specific number for like this dimension. And you can see here that this is a kind of schematic of the intensity of a psilocybin experience over time. And you can see that the kind of subjective experience follows like the pharmacodynamics of the substance. But it also has these kind of peaks and troughs of intensity within the peak of the actual kind of pharmacodynamics of the substance. So if we are kind of indexing things with Likert scales, what are we indexing? Are we indexing the peak here? Is the participant rating the average of this curve? Are the kind of recency effects biasing the way that they rate their experience? So we wanted to kind of integrate these temporal dynamics into the way that we actually measure subjective experience. So in comes a kind of methodology that forms the foundation of my PhD and an old PhD student of the lab that I'm in, the Consciousness and Cognition Lab run by Tristan Beckenstein. It's called Temporal Experience Tracing, and the fundamental idea is that we're now kind of quantifying the temporal dynamics of subjective experience rather than kind of compressing it into one number for each kind of dimension that you're interested in. The idea is really simple. After a participant does a kind of breathwork session, meditation session, psychedelic session, whatever, you provide them with an empty time series, and then rather than asking them, on a scale of 1 to 10, how blissful was your experience? Oh, it was a 7. Implying this kind of flat phenomenological property, you actually get the participant to just trace their experience over time. And so we actually have access to the kind of dynamics of experience here. So you can see that the participant here rated kind of falling into a non-blissful state and then transitioning into this kind of peak of bliss halfway through the session and then coming back to more of a baseline towards the end of it. So the idea here is that we actually have an idea of what a participant is experiencing and when, and so this makes it more tractable to be able to kind of bridge the gap between kind of EEG dynamics, but also experience dynamics as well. So this is the paper that I'm going to be talking about today. We combined temporal experience tracing, or TET, which I'm going to call it from now on, with low-density portable EEG devices that the participants wore at home when they were doing these breathwork sessions. We had 14 participants complete a breathwork course where they did 28 sessions for over 28 days, so one session a day. And these varied in length of time. So we had a huge neurophenomenological data set of about 301 breathwork sessions, which was horrible to pre-process. Took a really long time. So it's a pleasure to be able to kind of talk about it today in its finished product. Discussing the experimental design a little bit, as I said, we had 14 participants, and this is what the breathwork course looked like. So each participant was listening to a kind of pre-recorded audio track with instructions of how to breathe and when, but also kind of combined with like evocative music as well that form part of the breathwork sessions. So in week 1, you had these 20-minute long sessions. They did the same session each day for 7 days. Week 2 was 40 minutes a day. Week 3 was 60 minutes a day, and week 4 was 20 minutes a day. And so you have this kind of like dose-response profile as well to the experimental design, which is quite useful for us. So after each session, the participants did these TET traces. So they reported on 14 different dimensions in a kind of retrospective manner after each session. And they also wore these portable EEG devices. So we had like a kind of low-density 8-channel EEG headset that we provided to each participants. And they conducted the sessions within the kind of comfort of their own home. So it's more of a kind of like naturalistic design. So what did the breathwork kind of sessions look like? Well, as I said, they have these kind of like pre-recorded tracks that the participant would listen to that were subdivided into these kind of different conditions. So each participant would do the same sessions, so you had these kind of intersubjective standardization. So the first phase was this kind of introduction phase, which was uninstructed, some listening to kind of some music, but just settling into the practice. Then they had these breath phases where they followed the instructions of how to breathe and when. So often the cycle was 4 seconds in, 4 seconds out, kind of deep rhythmic breathing. Then they had these breath retention phases or breath hold phases where they would hold their breath for as long as they could within this period of time. Then they had this rest phase. So that was before they went into the next phase of doing the breathing, doing the breath hold, and then finishing at the end another uninstructed portion. So you have this kind of like, pre and post conditions as well as the kind of conditions of looking at the phases of the instructions of the breath work. So as I said, we had 14 different dimensions of experience. I'm packaging them into kind of principal components just for simplicity and for the interest of time. So we had these kind of metacognitive dimensions like meta-awareness, distraction, boredom, valence and emotion-based dimensions, bliss, emotional intensity, anxiety, bodily and intensity-based dimensions like disembodiment and release and tension, which kind of happened on an inverted axis, and physical effort and mental effort-based dimensions. So there was a lot of kind of subjective experiences that participants could rate on. And so with this, we had a huge amount of data. As I said, it was a massive pain to pre-process all of this. We had kind of a lot of traces on paper, which I had to take pictures of and scan. I had like one summer of just doing that and listening to podcasts. It was actually all right, to be fair. But what can you do with all this data? Well, we applied something called kind of k-means clustering to all of the data. And k-means clustering is a very simple kind of data-driven algorithm where it finds different clusters of data points. So as an illustration, what you can do is you can take, just on 2 dimensions of the data for now, you can take all the data points for bliss, all the data points for insightfulness, you apply this k-means clustering algorithm, you say, find the kind of clusters that separate maximally, blah, blah, blah. And you find that these clusters emerge, schematically at least, where in blue there are these low bliss, low insightfulness data points that simultaneously occur. And in orange, there are these kind of high bliss, high insightfulness data points. So you're doing this kind of dimensionality reduction, but not necessarily throwing out all of the dimensions of the data because you still have an idea of what the participant is experiencing at this kind of multi-dimensional level. So we applied k-means clustering on all 14 of the dimensions for all kind of 301 breathwork sessions. So what does this look like for the actual data? Because sometimes the clustering stuff is a little bit kind of obtuse, especially when you're applying it to phenomenological data. So this is an example of, this is actual data now, of one participant's TET traces, all 14 dimensions in the background, with the cluster category labeled in the background in either yellow or blue. Blue is cluster 1, yellow is cluster 2. And you can see that there is these kinds of transitions from cluster 2 into cluster 1 based on the TET traces. So there are these kind of dynamics of experience that unfold as a function of how they rated these TET traces, which the clustering algorithm is kind of extracting. And you can see that there are these like nuanced experience dynamics between and within sessions. So a participant can have more flat phenomenological sessions where they just have relatively flat TET traces, or they transition from cluster 2 into cluster 1. And this is, just one participant's data with all of the TET traces, but you can see that the clustering algorithm makes a bit more sense about what the participant was experiencing in terms of these like experience clusters. So I've said clusters quite a lot, and you might be asking like, okay, what do these actually mean? Like, what do these clusters represent? So we applied some kind of mixed modeling approaches on each dimension to see the kind of difference between each cluster on each individual dimension. And we found that all of these dimensions were significantly different between clusters, apart from disembodiment, interestingly. And in blue here, all of these dimensions were relatively higher in cluster 1, and all of these dimensions in yellow are relatively higher in cluster 2. We appraised this blue cluster, cluster 1, as psychedelic-like because it had relatively higher dimensions of bliss, spiritual experience, and insightfulness, which are all kind of subdimensions on oceanic boundlessness, which is reliably induced as a function of psychedelic administration. So you have this kind of like positive psychedelic-like experience cluster as a function of kind of what emerges during the breathwork sessions. And then you have this kind of opposing negative phenomenological cluster, which is high in physical effort, high in mental effort, high in anxiety, high in boredom. So to reiterate, you have this kind of psychedelic-like cluster in blue and this negative phenomenological cluster in yellow. So I've talked a lot about kind of what the TET traces are, how you can kind of work with the multidimensionality of the data, but what about the effects of the brain? Like, what do we do with all this brain data as well? So we kind of wanted to look at something called neurocomplexity, Lempel-Ziv complexity, which Naji and a few others have talked about yesterday. And we pre-registered our kind of hypotheses based on the entropic brain theory as a kind of theoretical framework for our data. Fundamentally, it's quite a simple theory, and the idea is that the kind of phenomenological richness of your experience is related to the kind of entropy of your brain. And there are lots of different ways in which you can compute entropy in the brain. But the idea here, I think, from Robin Carhart-Harris is that psychedelics increase subjective experiential richness, and so the entropy of your brain subsequently increases as well. And one way in which you can index kind of entropy, or, it's a crude measure, but it's been used quite a lot in psychedelic neuroscience, so we wanted to kind of follow that thread, is something called Lempel-Ziv complexity. And you can see here that as a function of psilocybin administration, Lempel-Ziv complexity in the brain increases compared to a kind of negligibly low dose of psilocybin. And these are kind of the time-derived effects of that. So, kind of from this theoretical notion that subjective experiential richness is associated with entropy in the brain, what should follow is that this psychedelic-like cluster should actually be higher in Lempel-Ziv complexity compared to this negative phenomenological cluster when you take in all the variants of the experimental design and integrate that. And interestingly, this is what we found. We found that across all of the weeks, kind of taking in the kind of variants of the sessions, Lempel-Ziv complexity was robustly higher in the psychedelic-like cluster compared to the negative phenomenological cluster. So these data points are just averages of Lempel-Ziv complexity for each session, and the lines are kind of joining the same sessions where they had different clusters within them. And you can see that this is a kind of relatively robust effect across all weeks. So a very brief interim summary that I want to kind of bang on about is that it seems that breathwork can induce these psychedelic-like experiences, and these experiences are associated with Lempel-Ziv complexity. But we wanted to kind of drill down and look at some other neural measures of like psychedelic correlates. So what we did is we looked at the literature again. We found that another robust neural correlate of the psychedelic state is alpha power. So alpha desynchronization occurs as a function of psychedelic administration, as you can see here from the same paper from Taylor-Lyons and colleagues. And so what we did, and this is maybe for the EEG nerds out there, we kind of used this toolbox called the FOOF toolbox, the Fitting Oscillations and 1/f toolbox. And we kind of parameterized the background activity, so the aperiodic exponent, which is basically like the steepness of the power spectral density. Flatter curve means there's more kind of fast wave activity contributing to the spectra and less slow wave activity. And then we separate this from the actual power spectral density, and then we parameterize the oscillatory alpha power here. So we look at just this, the kind of integral of this compared to the exponent. And so what did we find? Looking at the background kind of aperiodic activity, we found that the exponent flattens, so there's more kind of fast wave activity within these psychedelic-like experiences that breathwork can induce. But we actually found no difference in like these neurophenomenological correlates of alpha activity. So oscillatory alpha power was not a useful correlate to be able to separate the kind of experiences that people had during breathwork. However, Lempel-Ziv complexity and the aperiodic exponent actually were pretty robust to separate and kind of use as a neurophenomenological correlate. So I'm going to bang on my TET drum. I'm going to say TET is really useful. I'm obviously very biased, but applying this in this research allowed us to reveal these very nuanced experience dynamics that can emerge both across and within sessions. Using clustering, we found the psychedelic-like cluster was comparatively higher in neural complexity, but it showed no differences in the opposing cluster with oscillatory alpha power. So there is this kind of neural nuance between breathwork and psychedelics, which is quite interesting for us. So how similar are psychedelics and breathwork? I think the jury's out so far, but Martha will touch on this in just a moment, so I'm excited to hear her talk. I'd just like to talk about a little bit more work that we did within the lab. This was one paper from my PhD, looking at breathwork with TET and EEG. We also released a preprint last year looking at the medium and high dose DMT experiences using the same kind of approach, using TET, more high density EEG as well. And so we had some very interesting and quite contrasting results with this paper, which I'm super happy to talk about a bit later. And my third chapter looked at applying clustering on both data sets to see if we can look at the neurophenomenology of both of these states and actually see how similar breathwork and kind of DMT are at the neural and experiential levels. So thank you so much for bearing with me. Yeah, you can find the breathwork and DMT papers there. I'm always looking for opportunities and collaboration, so do get in touch. And thank you to my co-authors and everyone who made the breathwork study happen. So yeah, happy to answer any questions.